right, let's go through a very brief history of the atomic model. When we're talking about scientific models, we know that they have to be workable. If they are no longer workable, then we need to develop a new model. These models provide answers to our questions, and they show us a demonstration of how we believe the scientific phenomenon works. So in ancient times, our first mention of atoms or atomic models was from ancient Hindu writings. They basically said that everything is made up from very, very tiny particles. These particles make up everything in the universe. Then along comes Leucippus and Democritus. They used the Latin word atomus, meaning indivisible, to describe these tiny particles. And they said the same thing. Everything is made from these little tiny particles. Greek philosopher Aristotle comes along and says, matter is continuous. Everything that makes up anything continues to make up everything. Then we started realizing when chemistry comes along that Aristotle's model wasn't necessarily true. The stuff that makes up me isn't necessarily the same stuff that makes up the rocks. It's not the same stuff that makes up the trees. It's not the same stuff that makes up the air. So evidence started emerging that Aristotle was incorrect when he said that matter is continuous, everything is the same thing. Chemistry says that there are different types of atoms. So John Dalton, a chemist from England, comes along and says, you know what, an atom cannot be created or destroyed during a chemical reaction. It cannot be divided into smaller particles. And everything, whether it's gold or silver or helium or hydrogen or oxygen, is made up of only atoms. So that means atoms of one element are all alike. Atoms of one element are different from other elements. And we call his model the core envelope model because he said that different elements have different masses. So the thickness of the heat envelope was different. So atoms are tiny hard spheres. They cannot be split up, but they are different sizes, different masses based on their heat envelope. Along comes J.J. Thomson and says, hey, wait a second. An atom can be divided into smaller particles. He called these smaller particles electrons, and he said that these electrons are in a substance kind of like plum pudding. Kind of like vanilla pudding with chunks of plum. These chunks of electrons are all over the place in this plum pudding. So J.J. Thomson is known for his plum pudding model. Ernest Rutherford comes along and says, wait a second, there's a nucleus. A nucleus is in each of the atoms. He developed a gold foil experiment where he bombarded these gold foil pieces with particles, and these particles reflected off something in the middle, and he said, you know what, in this middle of this atom, there is a dense, tiny, positively charged region, and he called it a nucleus. So we give Rutherford the credit for having the nuclear model, not just plum pudding where there's chunks all over the place, but actually a dense portion in the center of the atom. Chadwick comes along and says there's not just protons, there are also neutrons, and these neutrons are in the nucleus, and that's how we get the mass of the atom. Then Niels Bohr comes along and says, wait a second, there are electrons of different energy levels. And Niels Bohr, we know, is correct when he says that, because within each atom there are varying energy levels. Some atoms have high energy levels, some atoms have low energy levels. So when we look at a Bohr model, named after Niels Bohr, we look at planetary orbits going around the nucleus. But this is not where we are today. Today we use a quantum model. These are not just Niels Bohr's orbitals. They are actually elliptical in their way that they move. So the electrons go from energy region to energy region, and they cannot occupy too much in one region, or they will go to another region. And we look at these orbitals, these tear-shaped regions, and we say we know that within these regions there are this many electrons, but what we don't know is at any one point where these electrons are. And when you get to chemistry with me, we will talk about the Heisenberg principle, and that is basically saying that at any one point in time, we cannot pinpoint where one is coming from or where an electron is going. They move completely randomly. So this is what we are currently using as our model for the atom. So over time, we have gone from very, very simple to very, very complex in our history of the atomic model.